or situations where you want to edit the dimensions of several features before regenerating the model. Auto Regenerate can be turned on or off by selecting or deselecting Auto Regenerate from the pop-up menu while a feature is being edited. While turned off, dimensions for multiple features can be edited without updating the geometry until you click Regenerate from the Quick Access toolbar. It can be turned back on the same way. Auto Regenerate allows you to immediately see the impact of your design changes in a real-time dynamic fashion, helping you to try out new ideas and make faster design decisions.
The Learning Connector is an essential tool to use whenever you're stuck, confused, or interested in learning more about a particular tool or command. To access the Learning Connector, click this icon in the top right corner. The Learning Connector window opens next to your model window so that you can work and learn at the same time. The Learning Connector is split up into 4 parts: recommended tutorials from the Learning Exchange, e-learning from PTC University, the Online Help Center, and the PTC Tech Support Knowledge Base. The Learning Connector is contextually sensitive. Notice how it reacts when I choose the Extrude tool. The Learning connector instantly updates all of the content. Here it shows a quick 2 to 3 minute tutorial on extruding a solid part. For a more formal lesson, you can select one of the e-learning topics. Here, Learning Connector gives you one-click access to thousands of lessons from PTC University. If you just want some quick information about a tool or command, you can check out the Help Center tab. Here you'll find many helpful articles about extruded features. Click About the Extruded feature, and a pop-up immediately appears for you to read and sift through. The articles found from the online Help Center can also be found by clicking the Help Center icon. Another available resource of information is the Knowledge Base, which provides recommendations from PTC technical support. The Learning Connector does not limit you to content related to the tool you're currently using. Using the Learning Connector search bar, you can search through all of the Learning Connector's content. Start working and learning simultaneously by taking advantage of the one-click access to learning content that the Learning Connector offers.
From billionaires to sharks, from creators to celebrities, I've had the chance to understand how they truly think about money. And here's something for you. Hi, I'm Sharan Hegde, founder of the 1% Club, and I began this company.
Right now I have an assembly open with no parts, so I'm going to click on Assemble, choose the block part, and I'm going to use an automatic constraint and just set it as the default. Click the check mark to complete the component placement. Now I'm going to do another assembly. I'm going to add the crankshaft part. Now rather than using an automatic constraint, I'm going to use the user-defined constraints and choose the pin connection set. Connection sets are very useful for making mechanisms because they restrict the motion of bodies, reducing the total possible degrees of freedom. This defines the kind of motion a component can have within a mechanism. For example, the pin constraint only allows rotational motion along the axis that you select during the definition. So I'm going to choose placement, and you see axis alignment. So first I'm going to click on the component. I'm going to choose this surface. Next I'm going to choose the assembly item, and I'm going to choose this surface. That's going to be the axis that this part is going to rotate about. Now it asks me to select the translation, so I'm going to select this face and have it aligned with this face. Now I'm going to click the check mark to complete this connection set. Now I'm going to use the assemble and create another pin, this time using the conrod part. So I'm going to again click on user defined, click on pin, then click on placement, click on component item, choose this surface, and I'm going to choose this surface on the assembly. Now to set the translation, I'm going to first click on the component item. Now I want to use a point that I can't currently see, so I'm going to click on the tools, I'm going to click on find, and now notice when you click on the find there's this box that opens up in the corner. Now I'm going to look for a point, so I'm going to scroll down this, choose point, and now I'm only going to want to look in the conrod part. Then click Find Now. Going to choose point 2, move it over to this box, and now press Close. Now notice when we click on Component Placement, that point was now selected for my translation reference. Now I'm going to select the assembly item and select a point on that. So I'm going to again use Tools, click on Find. It's already selected as a point. So now I'm going to click on Crankshaft Part, click on Find Now, and it's point 1, move it over, click on component placement, and you see it aligned those 2 points. Now I'm going to click on the check mark to complete this pin. The next part I'm going to add to the assembly is the end cap part. This is going to be a fixed part, so I'm just going to use the automatic constraints like earlier. So I'm going to first align this surface with this surface. Now I'm going to orient it by aligning these 2 surfaces, and the last constraint is to mate these 2 surfaces. And now this piece will be fully constrained, and click the check mark. Again, I'm going to insert another component, so I'm going to click on Assemble, going to click on the piston head part. This time I'm going to use another connection set, but this time it's going to be the cylinder. The cylinder connection translational motion along the defined axis. So for this first part, I'm going to click on Axis Alignment. I'm going to choose Tools, Find. Now I'm going to use Axes. And first I'm going to use the piston head. Find now. And I believe it is Axis 2. So I'm going to bring that over, close this, go to Component Placement, click on Assembly Item, and again I'm going to repeat this step, but this time I'm going to do it on the con rod. Click Find Now. I believe it is Axis 1. Move that over, press Close, Component Feature, and you see automatically aligns those two axes. Now I'm going to click on Placement, going to add another set. It's going to be another cylinder. This time I'm going to again click on Tools, Find, going to do an axis on the piston head, search Find Now. This time I'm going to use Axis 1. Now go back to Component Placement. We're going to click on the placement, click Assembly Item. Now again, choose Tools, Find. This time the axis is going to be on the block part. And again is Axis 1, so I'm just going to move that over. Click on Component Placement, and there you see we now have the cylinder, and it's able to move up and down in this area. And now we're going to click the check mark to finish the connection set. Now there's only one more part I want to add to this assembly, so I'm going to click on the Assemble button, choose the base part, and now I'm just going to use the automatic constraints. First I'm going to click on this surface and mate it with this surface, and now I'm going to choose this filleted edge and click it with this edge, and now the piece is fully constrained. Click OK. Now right now we have our mechanism and it's complete, but I want to see if it's actually going to move like the way I wanted it to. So we're going to click on Applications and now choose Mechanism. Now we're going to click on the Reconnect tool and choose Run. Notice there's going to be a confirmation box. It's just telling me that the mechanism assembly was succeeded, so I'm just going to click Yes and move on. Now I'm going to click on the Highlighted Bodies feature. This highlights the features in different colors depending on if it is able to move or if it is stationary. Objects highlighted in green are referred to as ground parts and will not move in the mechanism. Now to do a little test to make sure it's going to move, I'm going to click the Drag Components tool, and I'm going to choose a point on my con rod because I know that's going to be able to move because it's not highlighted green. Just click on it once and I'm going to scroll back, and you can see that my mechanism was
विदेश जाएगा अपना और आगे की पढ़ाई वहीं से करेगा नए जहानों को जान.
You can project or wrap a selected curve onto a surface or a set of surfaces. When you're projecting a curve, depending on the shape of the surface and the angle of the directional reference plane, the length of the projected curve can increase or decrease from its original size. Let's perform some projection examples on this curve. We'll get to wraps with the other curve later. Select the curve and start the Project tool. Then select the surface the curve will be projected onto. In this case, the wavy surface shown here. By default, the curve was projected in a direction normal to the curve sketch plane. And because of the curve of the surface, the length of the projected curve is increased. Head up to the dashboard, and you can activate the direction collector and select another plane as the direction reference. Notice that the shape of the projected curve changed when it was projected normal to datum plane DTM2. Now let's talk about wraps. The wrap feature can be used to wrap a curve onto a ruled surface, like a sticker being placed onto an aluminum can. The length of a wrapped curve doesn't change in length as it is applied to a surface. To wrap a curve onto this surface, start the Wrap tool from the Editing Group drop-down menu. Then select the curve to be wrapped. By default, the curve is wrapped about the center of the selected curve. But if the selected curve is a sketch, you can edit its definition and add a sketcher coordinate system to control the position of the wrap. With the sketcher coordinate system added to the sketched curve, you can now edit the definition of the wrap feature to be positioned about the coordinate system, rather than the center of the sketch. Whether you're projecting or wrapping curves onto selected surfaces, Creo Parametric enables you to do it in just a few clicks.
When creating a sketch that is full of symmetries, it's often much easier to use the mirror tool rather than manually recreating the geometry. Let's look at this spline as an example. Recreating the exact spline would be very tedious, so instead, let's use the mirror feature. First, insert a center line that will act as the mirror plane. Then click on the geometry you want to mirror, which in this case is the spline. Click Mirror, then click the center line. The mirror geometry is complete. All geometry that is made with the mirror tool will have these arrows showing the direction of the symmetry. Let's do this one more time, but this time I'll also mirror the mirrored entity. The sketch is now complete.
The first step is to create the new drawing file. So first I'm going to click on the New button in the corner, and I'm going to select Drawing and press OK. Now a dialog box is going to open and it's going to ask me for the default model. So I'm going to click on Browse, and I'm going to choose the drawing.part, and I'm going to leave the template as a C. And I'm going to press OK. The first thing I'm going to show you is how to move a part by clicking and dragging on it. So the first step is to highlight the part you want to move, then right click and uncheck Lock View Movement. Now when my cursor is over it, I can click on it and you can see I can move my feature wherever I want. Also notice that the other two features are going to stay in line with this feature regardless of where I move it. Another way of moving is by first highlighting the object you want to move, then right-clicking and selecting Properties, and then in the Categories tab, click on Origin, and you could change the X and Y locations of that drawing view. So I'm going to change these values so that the X and Y locations are both going to be 5. And these measurements are going from the bottom left corner of the sheet to the center of that drawing view. And I'm going to click Apply. Another thing you can do while in the Properties tab is to change the view orientation. To do this, click on View Type, and then where it says Model View Names, I'm going to change it to Bottom, and click Apply. Note that a dialog box is going to appear, and it's going to inform you that the other two views are also going to change because you reoriented this one. So just click Yes, and notice how the drawing changed. To add a projection view, click on Projection in the Model Views tab, then click on the view you wish to add the projection to, and then click where you want to add the projection. Notice that right now it's currently a shaded view and I want this to be hidden, so I'm going to right click and select Properties, and I'm going to click on View Display, and I'm going to change the display style from Follow Environment to Hidden. Now I'm going to click Apply and Close. To change the scale, click on any of the projections, then right click and select Properties, then click on Scale in the Categories tab and select Custom Scale, and I'm just going to make this 0.05 and click Apply. Notice that when you change the scale, a scale note is going to be created I'm just going to move this note down into the corner. Now I want to add a general view to my drawing, so I'm going to click on General, and I'm going to click Default and press OK. And now I'm going to click where I want the general view to be, so I'm going to click in this empty corner over here. Now let me just move this dialog box so you can see the general view. Right now the model is set to default orientation, and you could change the default orientation from trimetric to isometric or user defined, but I'm just going to leave it as trimetric and click Apply and press Close. With general views, it is often okay to leave it as a shaded view, unlike when creating a projected view, you want it to be hidden.
शानदार ऑनलाइन एक्शन गेम वॉर थंडर आपके उबाऊ सप्ताह के दिनों को खत्म करने के लिए तैयार है। प्रसिद्ध
I'm going to create an assembly drawing that will use balloons to reference the parts in the assembly to the bill of materials. The first step is to click on the Table tab, then select the table icon, click on Quick Tables, and choose Bomb Description Down. Now you're going to be prompted on where you want to place it. I'm going to place it in this bottom right hand corner. Now I'm going to make the corresponding balloons, and there are a few different ways to do this. One way is by clicking on Create Balloons and selecting Create Balloons All. This will create balloons only on the main view that the projections stem from. You can move the positions of balloons by first highlighting them and then clicking on the white boxes. And also notice that when one balloon is highlighted, it is also highlighted in the bill of materials, and vice versa. To clear balloons, click on the Balloons tab and select Clear Region, and then choose Yes. You can also create balloons based on a view. To do this, click on Create Balloons and select Create Balloons by View, then click on the view you want to create the balloons on. I'm going to choose this projection. And again, to get rid of the balloons, I'm going to click on the Balloons tab and click Clear Region and choose Yes. Now lastly, I will create balloons by component. So first I'm going to click on Create Balloons. Now I'm going to say Create Balloons by Component. And now you can select one or more items. So I'm just going to first select this plow, then click down on the scroll wheel, and notice that the balloon was created. Now I'm going to do this again, and I'm going to do multiple items. Now I'm going to create the balloons by component one more time, but this time I'm going to select the references on the model tree. Now press the scroll wheel, and all the balloons are created. Now I want to clean up the way the balloons look, so first I'm going to highlight all of the balloons by clicking on them and holding Control. And then I'm going to click Clean Up Balloons. Now I'm going to change the offset from View Outline. I'm going to check the box where it says Create Corresponding Snap Lines, because I find it makes fixing the balloons easier. And now you can preview what it's going to look like. And I'm going to press OK. Clean Up Balloons does a nice job, but it isn't perfect. Notice how balloon number 11 is going across the entire assembly to this bottom line. I'm just going to highlight it and then move it so that it's on the top line. Another thing to keep in mind when making balloons is that you shouldn't have any of the leaders cross each other. It's typically just bad convention to do so, so try and avoid it. And now I'm just going to get rid of these construction lines. Press delete, and there you have our
Do you know what will happen if you read one book every week? Let me share some.
An auxiliary view is a type of projection view that is projected at a right angle from a selected surface or normal to a selected axis. To create an auxiliary view that is projected from this view so that this circular surface and its pattern of 6 holes are displayed parallel to the drawing auxiliary from the Model Views group. If the selected direction reference is an edge, surface, or datum plane, then the view is projected at a right angle to the reference. This means this edge can be selected as the direction reference for this view. Then click to place the view. Another way to get the same view is to click Auxiliary and select this axis as the direction reference. If an axis is used as the direction reference, the view is projected normal to the axis. If we edit the properties of this view, we can see that the view type is auxiliary. The parent view is named General View axis. The option is set to None. Change this to Single and click Apply to see a single projection arrow added to the drawing. Change the option to Double and click OK to add a double arrow projection arrow. Creating and configuring auxiliary drawing views is easy in Creo Parametric. You'll be glad to know that if you need to place a flexible component into an assembly, it's not much different than placing a non-flexible one. There are just 2 additional steps in the process. As you can see, if you try placing a part into an assembly that contains a flexible definition, such as this flex contact, you're prompted to confirm whether you want to use the part's flexible definition. You could say no and not use the flexible definition, but in this case, we'll click Yes and use the part's flexible definition. The next step is to enter new values for the items that need to be flexible. The flexible definition of this contact has an angle dimension that's flexible. In the free state of the part, the angle dimension is 60, but perhaps you'd like that dimension changed to 90 when it's placed in the assembly. Notice that besides entering values, you could also set the dimension values such as curve length, distance, angle, area, or diameter. You'll see that a group of features named Test Pad has been added to the flexible definition of the component. By default, features added to the definition are resumed, but can be set to be suppressed if need be. You can use this to turn the display of features in your flexible component on or off. Next, confirm that the entire group of features will be suppressed, and then begin placing the component into the assembly as you would any other non-flexible component. You can see that the flexible part looks pretty different than the non-flexible part. If you cut a cross-section, see that it fits into the connector perfectly. If a change is made to the free state of the connector, the flexible version updates accordingly. Placing a flexible component uses the component in an assembled state while also maintaining the pre-assembled state of the model.
I have a story about a talking samosa. Can Gemini make it into a movie?
Of course! Upgrade Google Gemini for free!
College students can now upgrade Google Gemini for free and get access to video generation, free storage up to 2 TB and more.
In Creo Parametric, the shape of every revolved feature is based on a two-dimensional sketch and an axis of revolution. To create a revolve feature, you can either start the Revolve tool and then select the sketch you wish to revolve, or select the sketch first and then start the Revolve tool. If your sketch already contains an axis of revolution, it will be automatically revolved about that axis. If it doesn't, like the situation we have here, Creo Parametric will prompt you to select an existing edge or axis for the sketch to be revolved about. As soon as you select an axis of revolution, the sketch will be revolved around it. The axis of revolution can also be added to your sketch. To do this, just add a geometry type centerline in your sketch. This can be done using the Geometry Centerline tool found in the Datum group of the Sketch tab, or you can convert a sketch centerline to a geometry type centerline using the pop-up menu. Now if you start the Revolve tool, the sketch will be automatically revolved about the geometry centerline you added. To revolve about another axis, you can select Axis of Revolution in the dashboard.
What's up?
I don't know how to explain this, Kavya. It's a thrill.
Thrill.
In Creo Parametric, several types of measurements can be taken from your models. You can use these measurements to better understand the size and shape of your design. To find out what units a model was created in, and thus what units your measurement results will be displayed in, click File, Prepare, Model Properties. In the Materials section of the Model Properties dialog box, we can see that this model uses a unit system of millimeter, kilogram, and seconds. It's important to know what units will be used when evaluating the results of measurements that you'll be taking. The Measure group of the Analysis tab is where you can find a set of commonly used measuring tools: distance, length, angle, diameter, radius, area, and volume. To measure the diameter of a cylindrical surface, start the Diameter tool and select a cylindrical surface. The diameter of this surface is 14, and the diameter of this hole is 6. Start the Area tool to find the surface area of a selected surface. To measure the length of an edge, start the Length tool and select the edge. The Shift key can be used to select the chain of edges to be measured. Use the Angle tool to measure the angle between two selected surfaces. The Direction collector enables you to define the direction at which the angle is measured. The Distance tool enables you to measure the distance between selected entities. The Projection Direction collector enables you to define the direction or plane that the measurement is taken in. The Measure group of Creo Parametric's Analysis tab provides you with a robust set of commonly used measurement tools that can be used to evaluate your design. While working in the Flexible Modeling tab, you can find a powerful tool called the Modify Analytic tool in the While working in the Flexible Modeling tab, you can find a powerful tool called the Modify Analytic tool in the Transform ribbon group. The Modify Analytic feature provides the ability to change analytic geometry like cylinders, cones, spheres, and tori. The advantage of using Modify Analytic over Move or Offset is its ability to directly modify the size of the geometry as opposed to the feature's position or offset value. However, we're limited to changing only one surface and one type at a time. If we change the radius value of this cylindrical surface, you can see that the attached surfaces are recreated and kept tangent to the modified surface. Also, the existing rounds are automatically recreated, adapting to the new geometry. Additionally, if we look in the Attachment tab, we can see some interesting options like Create Side Surfaces, Extend and Intersect, and Bounding Edges. Let's have a closer look at these options. By selecting the side edge of the selected surface, we can give it a side surface. Or make the front face extend and intersect with the modified surface. If we change the angle of this cone beyond the part's geometry, we can use the Bounding Edges option to indicate where to stop.
हेलो क्या 199 वाला वर्कशॉप
Creo Parametric's new 3D Dragger interface has been added to make the process of orienting a component during the assembly process simple, fast, and intuitive. You'll see it as soon as you add a component to the assembly. Of course, you can still reorient a component by pressing the Ctrl and Alt keys while using the mouse buttons to pan and spin within the assembly. And if you don't want to see the new 3D Dragger, you can toggle its display on and off using this icon in the dashboard. But the 3D Dragger is a much faster, more interactive method that in many cases can improve your design efficiency. Each color-coded area of the 3D Dragger is used for a different type of orientation. The shaded arcs of the Dragger control rotation about the 3 axes. The shaded arrows translate the component along these axes. These small, translucent quadrants move the component in the 2D plane. And the small sphere at the center of the Dragger is used to move the component in any direction. Sometimes it's faster or even necessary to drag components along selected geometry, and it's easy to do that. Just right-click on the 3D Dragger and select Drag Along Geometry from the pop-up menu. Then select the geometry you want to drag along, for example, the edge of this shaft, and now that the edge is selected, the shaft will rotate or translate along that edge. The remaining degrees of freedom can't be used to manipulate the model while dragging along that edge, so they're grayed out. As additional degrees of freedom are reduced by adding more constraints to your assembly, you'll notice that those corresponding portions of the Dragger are also grayed out. An example is a shaft inserted in a hole, which limits motion to only one rotational axis and one translational axis, which are the shaft's remaining degrees of freedom. The new 3D Dragger provides you with an easier, more interactive method to move your components about in assembly, while respecting the limitations of the constraints you've specified.
Modifying pipeline routing. In this task, we modify existing pipeline segments. Disable all datum display types. In the ribbon, select the Applications tab. Click Piping from the Engineering group. Click Pipe from the Routing group. If necessary, click Display Thick Pipes from the View group to display thick pipelines. Select the pipe segment shown. Edit the line stock. In the ribbon, click Modify Pipeline from the Pipeline group. Select the Line Stock option. Click OK. 25A from the Modify Line Stock drop-down menu. Click Apply Changes. Notice that the line stock thickness updates on the pipeline as shown. Edit the bend radius for selected corners. Select the Corner Type option. Zoom in and select the upper corner on the pipeline as shown. Press Ctrl and select the lower corner on the pipeline as shown. Click OK. Edit the bend radius to 40. Click Apply Changes. Notice that the corner geometry updates as shown. Edit the corner type for selected corners. Select Miter Cut from the New Type drop-down menu. Edit the cut number to 3. Edit the cut length to 40. Click Apply Changes. Notice that the corner geometry updates as shown. Edit the flow direction. Select the flow direction option. Select the pipe segment shown. Click OK. Notice that the flow direction is indicated in the model as shown. Click the reverse button. Notice that the flow direction updates on the pipeline as shown. Click Accept Changes. This completes the demonstration.
Don't blame your brain lazy if you're struggling hard with procrastination. Because it might.
When you're working in flexible modeling, the Recognize and Select Ribbon group provides several shape selection tools to speed up your design process by allowing you to select the surface or surfaces of the geometry you want to change or move. Let's start by taking a look at the Boss and Boss with Secondary tools. They will select simple or more complex boss shapes. But with simple geometry like this, the difference is not that noticeable. However, if we select more complex geometry, you can see the difference when we make a selection using the Boss with Secondary tool. The Cut and Cut with Secondary tool will select simple or more complex cut shapes as well, but as you can see, if we use the Cut with Secondary tool, Creo Parametric also includes the pattern of holes on the bottom of the pocket. If you need to select multiple shapes or a combination of Boss and Cut selections, simply hold down the Control key. When the seed surface of the selection has multiple regions, the Surface Region Selection filter in the lower right can be used to isolate the correct region. After seeing Boss and Cut with Secondary tool, you can pretty easily guess how the Round and Round with Secondary tool will work. They can be used to select round pieces or full sets of round geometry. And just like the previous selection tools, you can hold down the Control key to create multiple round selections. The Recognize and Select ribbon provides you with the shape selections tools that make modeling faster and Draft features are typically used to apply angled surfaces to your design, so that the manufactured part can be pulled from the mold or casting tool it will be created in. Without draft, your manufactured part might get stuck in the tool used to produce it. To apply draft to your model, start the Draft tool. Every basic draft feature contains the following 4 items. Draft surfaces. These are the surfaces that the draft angle is applied to. In this example, the draft surfaces will be the cylindrical surfaces of this extrude. A draft hinge. That's the reference that the draft geometry pivots about. Go to the References tab and activate the Draft Hinges collector and select the top of the extrude to be the hinge. Notice that as you move the drag handle, the cylinder stays the same size at the hinge location, as draft geometry is added or removed starting from this reference. A pull direction. That's the direction used to measure the draft angle. You can see in the References tab that by default, the pull direction reference is the same as the draft hinge reference. The yellow arrow in the graphics area displays the pull direction. This is the direction in which your mold or casting tool is pulled away from the finished part. And the draft angle that's applied to your model. It can be as large as plus or minus 30 degrees. If we move to the middle extrusion, we can apply a draft to the 4 side surfaces. Only this time, the draft hinge will be the datum plane running through the center of the extrusion. Notice that the draft angle pivots on both sides of the draft hinge. For our last example, we'll add draft to the 4 side surfaces and use the base of the model as the draft hinge. Notice that the size of the resulting geometry always stays the same at the draft hinge. The draft feature in Creo Parametric is a powerful tool that enables you to create manufacturable, molded designs.
From billionaires to sharks, from creators to celebrities, I've had the chance to understand how they.
When you're working with sheet metal design in Creo Parametric, you can quickly see a preview of your flat pattern by turning on the Flat Pattern Preview from the Graphics toolbar. Notice that the preview window contains its own graphics toolbar. You can toggle the bounding box display to see the overall dimensions of the flat pattern's bounding box. This way, you can quickly monitor the flat pattern size as you progress through your design. Click Flat Pattern Preview again to toggle off its display. A quick look at the model tree confirms that the preview did not create a feature in the part. It's simply a display that can be toggled on and off as necessary. A flat pattern feature unbends your entire part just like an unbend feature does, only the flat pattern feature is always automatically located at the end of the model tree. Start the Flat Pattern tool from the Bends group, and your model will automatically be flattened about the default fixed surface highlighted in green. You can select another fixed surface to change the orientation of the flat pattern. Notice that when you create a flange feature, it's automatically inserted before the flat pattern feature. When the new feature is completed, the flat pattern will be resumed. This flat pattern feature behavior enables you to create a flat pattern early in the design process, so that you can simultaneously create and detail your sheet metal designs.
Tutorials for selecting and removing multiple surfaces or gaps for removal. The Removal tool helps you remove geometry without the need to alter feature history or redefine any other number of features. For this demonstration, I want to use the Remove feature to remove parts of these rounds. The first step is to select all the rounds. Now that all the rounds are selected, I want to click on the Editing tab and then click Remove. As of right now, the Remove feature wants to remove every single part of the rounds, but I want to keep these quarter rounds intact. So to do that, I'm going to click Options and then click in the Exclude Contour box and select the parts of the rounds I want to keep. Now I can press OK, and you'll see that the remove tool was able to delete the other rounds but keep the other rounds there. I was able to change the feature without being forced to redefine the feature or alter any feature history.
Numbers make my head spin. How can I make this easy? Bruh, for students.
You can create a new surface quilt by offsetting it a distance from another quilt or solid surface. Notice in the menu ribbon, however, that the offset tool is currently grayed out and can't be selected. This is because an offset reference must be pre-selected before starting the offset tool. We'll select this surface quilt and then start the offset tool. If you need to flip the direction of the offset, you can use the direction arrow in the graphics area or the button in the dashboard. To better see how the offset surface works, let's change to a front view and open the Options tab. Currently, we're offsetting the surface normal to the selected surface. But if we offset the surface, you'll see that the preview geometry fails. To bring back your preview, edit the offset type to Automatic Fit, which will offset the surface along an axis to create an offset that is approximately the same as the original. This fit type is useful in cases where the normal to surface fit won't work. Next, we're going to enable the display of coordinate systems and then edit the offset type to be Controlled Fit. If we clear the X direction checkbox, translation in that direction will be prevented. Notice the difference in how the new surface's shape is maintained when you change the offset, when translation along one of the axes is prevented. For the next offset example, we need to hide these two surfaces and unhide Extrude 2. Remember to select the quilt first, then start the offset tool. Flip the offset direction and edit offset value to be 20. Then head up to the dashboard, open the Options tab, and enable Create Side Surfaces. If we click Preview, you can see that the side surfaces were automatically added between the original surface and the offset. The Offset tool enables you to easily create a surface quilt by offsetting it a distance from another quilt or solid surface, and even create the side surfaces to create a closed volume.
Leveraging geometry rules. In this task, we use the geometry rules selection tools. Disable all datum display types. In the ribbon, select the Flexible Modeling tab. Select the front face, as shown. Note that the geometry rules are activated when the seed surface is selected. Click Geometry Rules from the Recognize and Select group. In the Geometry Rules dialog box, select the Coplanar checkbox. Note, the front face of the larger protrusion is now highlighted because it is coplanar with the seed surface. Clear the Coplanar checkbox. Select the Parallel checkbox. Note, not only is the previous coplanar surface selected, but all parallel surfaces in the model are also now highlighted. Note, remember that geometry rules are dynamic rules that are applied during the surface collection process. These rules are evaluated with every model regeneration. Click OK to close the Geometry Rules dialog box. Click in the background of the graphics window to deselect all geometry. Select the cylindrical surface as shown. Click Geometry Rules. Select the Coaxial checkbox. Note, not only is the obvious whole surface highlighted, but also the top chamfer and the bottom round surfaces are now highlighted. Click OK to close the Geometry Rules dialog box. Click in the background of the graphics window to deselect.
Secondary flat walls are planar walls that are attached to a straight edge of an existing wall. The final shape of the wall is then defined by specifying a number of predefined shapes, sketching a user-defined shape, or editing elements of the feature. Let's see an example by starting the Flat Wall tool from the Shapes group and applying the wall to this edge. The default shape of the wall is rectangular, but you can use the Shape drop-down menu in the dashboard to change the shape to a trapezoid, a T, or use a defined shape. In this example, we'll use the L shape. The wall's bend radius can be easily changed from being equal to the wall thickness to some other value. In this case, we'll use 5. You can also edit the bend angle from 90 to something else. The size of the L shape can also be edited. Here you can see the taller side is lengthened directly within the model, but if you click Shape from the dashboard, you can make edits there too, such as making the shorter side 20. To create a user-defined shape, enter Sketch mode by clicking Sketch from the Shape tab. We can see the sketch of this wall, and we can edit it, like adding a fillet to a corner of the wall using the Circular Fillet tool. Creo Parametric provides you with several convenient and intuitive starting points to quickly create secondary flat walls, and makes custom designs simple too.
ఇప్పుడు నాతో ఉన్న ఒక వ్యక్తి పంతొమ్మిదేళ్ల వయసులోనే మైండ్లో ఈఐ పెట్టుకొని బయట ఏఐ ఆర్టిఫిషియల్ ఇంటెలిజెన్స్ అనే ఒక అద్భుతమైన టూల్ను ఉపయోగించి వన్ ఆఫ్ ద యంగెస్ట్ అచీవర్స్ ఆఫ్ అవర్ కంట్రీ వీ హ్యావ్ అవినాష్ విత్ అస్. సో అవినాష్, మీ జర్నీ ఎలా స్టార్ట్ అయింది?
2021 మేలో we're making a revenue of first week of May we're making a revenue of 25 lakhs. Lot of our clients are into cryptocurrency అన్నమాట. If you remember 2021 లోనే క్రిప్టో పడిపోయింది. 25 lakhs నుంచి 4 lakhs రెవెన్యూ డిప్ అయ్యి ఓవర్ ఓన్లీ 2 weeks లోనే 25 lakhs రెవెన్యూ 4 lakhs కి వెళ్ళిపోయింది అనమాట. సో ఏం చేయాలో తెలియని స్థితి. ఐ వాజ్ ఇంటూ లిటిల్ డిప్రెషన్ 2 weeks లో. అదే టైంలో మా మదర్కి ఒక వ్యాక్సిన్ అయింది. ఆ రూల్ వల్ల షీ పాస్డ్ అవే కోవిడ్. Professionally, personally, everything was disrupted. 2 months I was disrupted. Now yearly monthly revenue 2 lakhs ki padipoyindi 4 lakhs nunchi. I was suicidal. అప్పుడు ఫస్ట్ టైం సూసైడికల్గా అనిపించింది. నేను మా ఫాదర్కి 40 lakhs రెవెన్యూ లాస్ అయినప్పుడు, నాకు బ్యాక్లాగ్స్ అన్నీ ఉన్నప్పుడు ఫస్ట్ టైం అనిపించింది. సమ్హౌ ఐ మేనేజ్డ్. ఒక్కసారి షాటర్ అయినప్పుడు మళ్ళీ లెగటమే చాలా కష్టం అనుకుంటే నాకు రెండోసారి అయింది. థర్డ్ ఇయర్లోనే మళ్ళీ బిజినెస్ 2019 నుంచి 2021 ఏం చేయాలో తెలియని స్థితిలో దెన్ సమ్వన్ ఇంట్రడ్యూస్ టు ఏఐ. అక్కడ స్టార్ట్ అయింది నా జర్నీ అనమాట. 2021 మే జూన్ జూలై ఆ టైంలో ఐ వాజ్ ఇన్ టు ఏఐ. జాస్పర్ అనే ఒక ఏఐ టూల్ అనమాట. బరాక్ ఒబామా నుంచి బాహుబలి దాకా ఏ టాపిక్ అడిగినా చిటుకులో మొత్తం పారాగ్రాఫ్లు రాసి ఇచ్చేస్తారు. ఇది ఇంకా చాట్ జీపీటీకి ముందు. చాట్ జీపీటీ హ్యాపెండ్ ఇన్ 2022 నవంబర్ కదా. 1.5 year ముందు నాకు ఇది అనిపించేటప్పటికి అసలు ఏంటిది ఇంత అద్భుతమా అని నాకు అనిపించి కాంటెంట్ మార్కెటింగ్ డీల్స్ నేను చేశాను. అప్పుడు ఏదైతే డిజిటల్ మార్కెటింగ్ చేశాను, డిజిటల్ మార్కెటింగ్లో కాంటెంట్ మార్కెటింగ్లోకి వచ్చేసి క్లయింట్స్కి కాంటెంట్ రాసి ఆ కాంటెంట్ ద్వారా SEO ఆప్టిమైజేషన్స్ అన్నీ చేసి 4 ఎంప్లాయీలతో చేసే పనిని 1 ఎంప్లాయీతో చేయించేవాడిని. సో అలా 3 టీమ్స్గా పెట్టి 12 members ఉండాల్సింది 3 members ఇట్లా అయిపోయి అదే లైక్ వాళ్ళకి నేను శాలరీస్ ఇవ్వాలంటే ఇట్ వుడ్ హ్యావ్ కాస్టెడ్ మీ 4-5 lakhs ఆన్ అ మంత్లీ బేసిస్. ఈ ఎంప్లాయ్ 14 members-కి. నౌ విత్ ద హెల్ప్ ఆఫ్ AI tool and couple of employees, AI tool మహా అయితే ఒక $50, 4,000-5,000 rupees అక్కడ స్టార్ట్ అయింది. ఆ ఒక్క AI tool అలా 12 AI tools అయినాయి. 12 AI tools అలా 12 clients అయ్యారు. 12 మొత్తం వల్ల నెక్స్ట్ 6 months లో we made again back to 25 lakhs.
Fantastic.
That's the journey.
అలా సింపుల్గా అర్థమయ్యేటట్టు, రైట్, అందరికీ అర్థమయ్యేటట్టు AI అంటే ఏంటి అసలు?
సో AI అంటే ఆర్టిఫిషియల్ ఇంటెలిజెన్స్, అన్ ఆల్గరిథం దట్ థింక్స్ లైక్ హ్యూమన్. అది ఒక హ్యూమన్ లాగా థింక్ చేసే ఒక చిన్న సాఫ్ట్వేర్, అంతే. దట్స్ AI.
ఆర్టిఫిషియల్ ఇంటెలిజెన్స్ రావటం వల్ల చాలా మంది జాబ్లెస్ అవుతారు, ఆర్ చాలా జాబ్స్ పోతాయి.
రీసెంట్లీ కునాల్ షా, ద ఫౌండర్ ఆఫ్ క్రెడ్, ఆయన కూడా అన్నారు అనమాట ఏమంటే 70 నెక్స్ట్ 7 years లో there is going to be a wave which we are not prepared for. Like upskilling to be AI ready, almost 1 crore Indians or maybe 40 or 50 or whatever crore Indians is very difficult. ఇంత ఫాస్ట్ గా అప్స్కిల్లింగ్ అనేది వీళ్ళకి ప్రాంప్ట్ ఇంజనీరింగ్ నేర్పించడం, చాట్ జీపీటీ ఎలా యూజ్ చేయడం నేర్పించడం, స్టూడెంట్స్ కి, వర్కింగ్ ప్రొఫెషనల్స్ కి, బిజినెస్ మ్యాన్ కి, గవర్నమెంట్ కి, ఇన్ని మందికి ఎట్ దిస్ స్కేల్ నాట్ పాసిబుల్. So there is going to be a job loss in every field you could think of in a white collar job category. Like you think of developers, editors, content writers, graphic designers, digital marketers, you name one industry in white collar, category, I will say you how it will be impacted. Aa level lo impact avutundi, and that's proven. That's one inevitable anamata. We can't stop. Dukan annako company, they replaced 90% of this technical support team with one AI chatbot. అంటే వాళ్ళ 100 మంది ఉంటే 90 మందిని రిప్లేస్ చేసేసారు వాళ్ళ కస్టమర్ సపోర్ట్ టీంలో. ఒక్క AI బాట్ $200 పడుతుంది వాళ్ళకి, ఆర్ మేబీ ఒక $1,000 పడుతుంది. 100 మంది శాలరీలు ఎంత, లేకపోతే ఈ $2,000 $1,000 మంత్లీ AI బాట్ కి చేయాల్సింది. విత్ ఇన్ సెకండ్స్ మనిషి కన్నా పర్ఫెక్ట్ గా చాట్ బాట్ ఆన్సర్ ఇస్తుంది. విత్ ఇన్ మినిట్స్ మనిషి కన్నా ప్రాపర్ రిజల్యూషన్, అతనికి ఏం చేయాలి అనో, ఆ కస్టమర్కి ప్రాబ్లం వస్తే టెక్నికల్లీ ఎలా ఫిక్స్ చేయాలనేది AI ఈజ్ ఆన్సరింగ్ బెటర్ అని ఆయన CEO అఫీషియల్ ట్విట్టర్లో ఇచ్చేసారు. సో ఇలా అవ్వకూడదు, నా సిచ్యువేషన్లో వేరే వాళ్ళు ఉండకూడదు అని లాస్ట్ 6 months నుంచి ఐఎమ్ డూయింగ్ ఫ్రీ మాస్టర్ క్లాస్ అన్నమాట. ఆల్మోస్ట్ ఒక 40,000 members across the world, 25 countries and 5 continents of the world attend for free for 3.5 hours every Saturday. I do this.
Wow, fantastic. If you want to date success, update yourself, else AI will take over.
Exactly.
AJ. What's up?
I don't know how to explain this, Kavya. It's a thrill.
Thrill?
And it goes on and on and on. It's a turbocharged, incredible feeling.
Turbocharged?
Thrill has a new shape.
Ready for it.
Thrilled for it.
Presenting Franks with Turbo Booster Jet Engine.
Nexa.
Repeating component placement. In the first task, repeat the placement of a component and vary a single reference. First, we disable all datum display types. Then in the model tree, we click Settings, Tree Filters, and in the display area, we select Placement Folder and click OK. In the model tree, we right-click the first instance of the 518 bolt and we select Repeat. In the Variable Assembly References field, we select the first coincident reference and then we click Add. We then select the inside surfaces of these three holes and click Confirm to complete the placement. In this task, we repeat the placement of a component and vary two references. So in the model tree, we right-click the last instance of the 625 bolt and select Repeat. We then select both coincident references and click Add. We then rotate the model slightly and we select the cylindrical surface of this hole and the flat surface of the model. Then click Confirm to complete the placement. In this task, we repeat the placement of another component using the model tree. So in the model tree, we expand the first instance of the 625 bolt. We then expand the placement node, and we expand the Set25 node. We right-click the top coincident constraint and select Repeat. We then select the cylindrical surface of the hole located at the top of the gearbox and click Complete Component. Note that when you use this method, you can only repeat one component at a time.
While the world buffers, you prompt, create, launch. Zoho Creator, because ideas shouldn't wait.
गली गली
Welcome to the Removing Webs demonstration. In this demonstration, we will create a new part by importing point cloud data and then creating a wrap model. First, we will import the point cloud data. We will select bottle.pts. We want to select facet from the import type. We can now click OK to import the facet data and create a new file. Now that the point cloud data has been imported, we want to create a wrap. Select Wrap from the phase group in the ribbon. We will now use the Remove Webs command to remove the web facets in the area inside of the handle. Select Remove Webs from the Wrap group. In the lower left-hand corner of the screen, notice the current facet count 177,706. We will now zoom in and rotate the model to see inside the handle. We want to enter measurement mode, so we will now click Select 2 points from the Remove Webs dialog box. We will now select the ends of a facet edge. The measurement we just